Consider the accompanying graph of f of x is equal to k times 1 over x to the n, where n is a positive integer. Let's start with part B. Is k greater than 0 or is k less than 0? In other words, is k positive or is k negative? Well, to answer that question, we can find f of 1. Let's first of all do it symbolically using the given formula. To find f of 1, we simply substitute 1 for each x in the formula. We get k times 1 over 1 raised to the n power. Now, even though we don't know what n is, we do know that when we raise 1 to any power, we get the number 1. In this case, we know that n is a positive integer. So 1 to the first is 1, 1 squared is 1, 1 cubed is 1. No matter what n is, 1 to the n will be equal to the number 1. And 1 goes into 1 one time, and 1 times k is k. So f of 1 is equal to k. Now, to figure out whether k is positive or negative, we can use the graph. We can evaluate f of 1. We first of all locate 1 along the x-axis. We go down vertically until we hit the graph of the function. And then we look horizontally across, and we see that the corresponding y value is approximately negative 1. Negative 1 is a negative number, so we now know that k is less than 0. Now let's go back to part A and see if we can determine whether n is even or odd. Let's use our calculator to explore. First of all, we'll go to y equals, and we'll enter our function k times 1 over x to the n. Use the alpha key to enter k and n. Once you've entered k times 1 over x raised to the n, then go to the home screen by pressing second and then mode. We've determined that k is approximately negative 1, so let's first of all store negative 1 as the value of k. Enter negative 1 and then store that as the letter k. Next, let's explore some values of n. We know that n is a positive integer, and the smallest positive integer is n is equal to 1. 1's an odd number, so we're going to test an odd number first. Take 1 and store that as the letter n. Next, we're going to create a good viewing window, one that matches the given window on our exercise. We look along the x-axis and we see that the x values range from negative 5 to 5 with a scale of 1. So we enter negative 5 for x minimum, 5 for x maximum, and 1 for x scale. Looking along our y-axis, we see that the values range from negative 5 to 1 with a scale of 1. So we enter negative 5 for y minimum, 1 for y maximum, and 1 for y scale. Then we go to graph. And we see that the resulting graph does not match our given graph. On the right hand side, the graph looks much the same as the one that's given, but to the left of the y-axis, the y values are positive rather than negative. So this indicates that n is not 1, n is not an odd integer. Let's try an even integer. We'll go back to our home screen, and this time we'll let n be 2. Go back to our graph. And this time we see that the graph on the calculator screen matches the given graph quite well. So it's possible that n is equal to 2 and k is negative 1. The key thing is that n is even. For part C, we're asked, is f of negative 1 greater than 0 or is f of negative 1 less than 0? To determine that graphically, we first of all locate negative 1 along the x-axis. We go down vertically until we hit the graph of our function, and then we look horizontally across to the y-axis. We see that the corresponding y value is approximately negative 1. So f of negative 1 is approximately negative 1. Negative 1 is less than 0, so we know that f of negative 1 is less than 0.